Alright, so this is the second part of 14 where we're trying to find, well, last time we found his velocity at the very lip of the half pipe. Now we want to find his velocity right here, right at the very bottom. So I'm going to call that, I'll call this V1, I'll call this V2. Doesn't matter what you call it as long as you can distinguish between the two. So now all of his energy should be kinetic. And here, all of his energy was potential. So for this one, and I'm going to do this, try to keep this picture up here, but I'll squeeze it in over here. All of my potential energy that I found up here, since we had, let me squeeze that in, since we had a total height, we could find that, it was mgh. All of that potential is now turned into kinetic because we're at the bottom of the ramp. So if all of the potential equals all of the kinetic, and you do mgh2 is equal to 1/2 mv squared, this is v2. This is the same setup I had back in number 10, where when you solve for all this and you cancel out the masses and you move the 2 over and you rearrange, take the square root, you'll end up with the velocity equal to square root of 2gh, and this was specifically h2 in this case for this problem. Now, if you want to see how that was done, go back and look at the video for problem number 10, because I'm just going to move on from here. Now this was falling from a total height of 7 meters. So the velocity is equal to square root of 2gh, and this is 7 meters. I should put in 10 for the g, but square root of 2 times this would be 10. So that'd be 20 times 7 meters. Velocity equals square root of 140 meters squared per second squared, because again this was meters per second squared from the acceleration. And now I have to take the square root of this. So square root of 140. So square root of 10 would be 100, or 10 times 10 would be 100. 11 times 11 would be 121. 12 times 12 would be 144. It's close to that, so it's a little less than 12. I'm going to say 11.9, maybe 11.8. I don't know. I'm going to call that approximately. If you have a calculator, great. Do the actual thing, but now I have my velocity at the bottom. I call that V2, at the bottom of the half pipe. All because I set the potential energy up here at the top when it's all potential energy equal to the kinetic energy at the bottom when it's all kinetic energy, because all that energy has to stay the same. But in this case, it's a little easier because all of the potential is turned into all of the kinetic. In the first part, I only had some of the potential turning into kinetic, and it was in between part. Now, could you have used this same process for the first part? Probably could have, and you would have fallen a different height. Let me scoot up here. You would have fallen a different height than you would have fallen the whole height. You would have used a different height in this location for this h. But you could have used that same thought process. So, again, you're dealing with total energy staying the same. You're dealing with the fact that potential energy is mgh, you're dealing with the fact that kinetic energy is 1/2 mv squared. Everything else is just a unique combination of those three ideas. So hope that has helped. Good luck on your test on Friday.